Hello, everyone, and a huge thank you for joining us today for today's panel. This is a lead dev online discussion created in partnership with Harness. This discussion will last about 45 minutes, after which both myself and the panelists will head over to the lead dev Slack to answer some of your questions in the panel Q&A. That's more for, if there's more questions or more comments. And I think it's a hot topic, so we might have that. And I just really want to point everyone, I just dropped it in the chat now. It's really a great community of engineering leaders supporting and learning from each other. So I think it's a good place to be, a very positive Slack community. But for this particular panel, because of the topic, we'll be answering questions live and throughout, and we want a lot of audience participation. So please jump in the chat and share your experiences. Of course, that's if you're joining us live. If you're watching it later, well, happy to have you and learn from it. Okay, so today we're talking about both a perennial and a nascent topic, tech debt. It's something that everyone thinks is a problem. Developers have been complaining about it all the time. They've always had too much tech debt slowing them down, and documentation was the thing till recently. No one wants to spend time paying it down because it's not sexy work. And actually, AI could help with it. But AI is probably creating technical debt faster than it can help with. So yeah, that's what we're talking about today. We definitely want to know your experience and how you're dealing with it, both if you're having more or less, what's happening. So to kick off, we're going to have a poll, and then we'll do introductions while you're answering the poll. So thank you for that. Basically, we're asking today, how do you think AI is impacting your technical debt? Is it making it worse? Is it better? It's about the same. So yeah, let's get started with some introductions. I'm Jen Riggins. I'm everyone's favorite tech journalist and host specializing in the developer experience. Today, I'll be joined by Grace, Birgitta, and Aaron, ready to share their experiences and insights. So can you each introduce yourself? Grace, why don't you start?
Hello, hi everyone. I'm Grace Tarani. I'm a DevOps engineer at NVIDIA. At NVIDIA, I own production CI/CD pipelines, and I lead the integrations of AI into our core automations. Over the past 4 years of my work, I have evolved from managing a single pipeline to building internal platforms and to designing AI agents architectures that actually orchestrate our entire stack. And that journey is exactly what brought me to what we're discussing today. Well, actually, I was the one, like the first hand to see how fast AI can generate a beautiful mess. He's a professional in that. And I am a big believer that engineers should do what they are the best at, like judgment, design, slow and careful decisions that determines how system grow gracefully and like grow to be like big systems. And one more thing about me, I think about AI workflows the way I think about everything, and I'm obsessed with. And yes, you can see probably the perfumes behind me. I am a collector of niche fragrances, and I'm fascinated by the way perfumers build their scents through harmony and notes and accords, and that's the way I think about AI as well. One more thing you can't see, but you still get to know about me is that I love catching last-minute flights to places I have no idea about their language, but I love to do that. That's me.
Yes, absolutely. And I think what was interesting about what you were talking about, the purpose of the developer hasn't changed or the engineer hasn't changed, but it's about truly understanding what your unique value proposition is. And that is the thing not to replace with AI. And it was never coding.
Exactly.
Yeah, absolutely. Birgitta, would you like to go next?
Yeah. Hi, everybody. I'm Birgitta. I'm based in Berlin, in Germany, and I work for a software consultancy called ThoughtWorks. I'm a distinguished engineer there. And over the past 3 years, I've had a full-time role as kind of a subject matter expert in the topic of using AI on software delivery teams to make the teams better, because that's ultimately what we want, right? Make them better, not just faster. And I've recently written a lot about this, one of those new buzzwords like harness engineering, and how to maybe catch some of the quality problems at least before they even make it into a pull request.
And finally, with the mention of harness, which isn't an AI harness, but now is probably trending in name as well. Aaron, please introduce yourself.
Yeah, sure. It definitely doesn't hurt that harnesses in general are in the zeitgeist right now, probably more than they ever have been. Yeah, but my name's Aaron Newcomb. I'm a senior manager here at Harness, the company. People know us mostly for our CD platform, but we have a whole host of other products that we sell, including feature flags. And since I started working on feature flags here at Harness, one of the biggest things that comes up with customers is how do I deal with tech debt? Because with feature flags, you're automatically creating essentially tech debt every time you create a flag, but don't take it out of your code base later. And it can be a real problem, especially at scale. So yeah, that's why I'm excited to be with the other hosts today, which have a vast knowledge about how people are dealing with this. And I would also encourage people to go ahead and use that chat if they're watching live, because I'd love to hear, the types of problems people are facing. There's all kinds of different tech debt that we deal with. So, what's the worst part of it, or what's the worst type that you're dealing with? And, kind of maybe some strategies that we could share with the rest of the audience. So yeah, use that chat box.
Absolutely. Thank you all so much. And thank you to our live listeners for participating. So we've got some responses. To the question of how do you think AI is impacting your tech debt? Like most developer productivity gains right now, they're vibes. They're kind of what you feel. They're not always measurable. And I think this is one of them, but we'll talk about that, don't worry. So about 65% have said that AI has made their tech debt worse. 13% said it's made it better. That's very interesting. We definitely want to hear from you, especially. And about 30% said it's about the same. So that just gives us a little pulse for our audience, but we really do want to hear live, for those joining us live, what you think. So as a journalist, I always want to start with the definition, which is a super nerdy way to do, but I would like to hear from everyone, like, let's create a baseline. What do we mean by technical debt? What's the problem? How bad is it? What are y'all hearing in the field?
Who wants to go first? I'll go first since I'm speaking. Yeah, I mean, for me, tech debt has always just been anything, and it's not only relegated to software, it can be hardware as well. But anything that tends to linger longer than it should, gets ignored, and causes problems later. Something, a classic example is either on a personal level or maybe at a startup, you develop some sort of a system or software, and you're moving so quickly that you get to the point where it's good enough. I do this in my personal projects all the time. It's like, I know that should be better. I know there's things that I should do, either for security's sake or for efficiency's sake or anything like that. And I get to the point where it's good enough and I just have to move on to meet a deadline or whatever. And then that code or that piece of software that I wrote that I know that really should be improved or gotten rid of later just stays there and then comes back to haunt you. That's the classic example that I usually see.
So tech debt is a ghost.
It can be a ghost, but it's a ghost that comes back to haunt you.
Well, yes.
Yeah,
the ghost
exactly.
you eventually know about in your cupboard.
Yeah.
Yeah, this goes, Jennifer, I guess also in the sense of like that it's hard to, you kind of hard to define. I think it's become this catch-all term that just people use for anything that they see in the architecture or in the code that they don't like. Either they don't like anymore or they don't like in the first place. And I think we also put into the resources a link to Martin Fowler's website where he has this definition of the technical debt quadrant, which I really like because it brings home like part of the original definition, which was by Ward Cunningham, I think, that was about that it also plays a huge role, like if it's deliberate, if it's like, because like the idea is also that very often we take on this debt deliberately and we know we're going to have to pay an interest and we have to going to pay it off later. But sometimes we do it deliberately. Like Aaron, you gave the example of like sometimes you just need to ship something but you're going to have to fix it later, right? And then often people don't pay it off, right? So there's like all kinds of nuances to it that I think make it easier to talk about it. But yeah, because as engineers, we often use it like very fuzzily, like we've been over the years, I think, kind of like annoying our like business and product and project management counterparts, where they can't even distinguish anymore when it's almost like crying wolf, right? Like I've seen a lot of teams where they've just been ignored because nobody could distinguish anymore. Is this really problematic or not, this particular thing that they're talking about, right?
Well, I'll add one thing here. Actually, I think that technical debt has always existed, but I think that AI changed the speed at which it accumulates today, you know? So
Mhm.
what used to take team weeks to build and maybe weeks to actually get wrong, now it takes minutes, you know? So the debt is the same animal haunting us, but it's breeding like way faster than ever now, you know? And the dangerous part of the whole of this is that it looks clean on the surface. I mean, AI generated code can look perfectly fine and still be like sometimes deeply inconsistent. That's the problem. And sometimes it will be like hard and maybe sometimes impossible to maintain it 6 months later. And that's the new shape of the problem today. That's how I see it. So yeah.
And also because AI does it when we don't look at what's happening, there's a lot more of this inadvertent tech debt, right? Like I was talking about, there's some that's actually like we do intentionally, right? But there's a lot more inadvertent and maybe more reckless. That's one of the dimensions in the quadrant as well, tech debt, than maybe previously when we were going slower and actually thinking it through.
Yeah, yeah. And Michael actually brought this up. I was just noticing a comment. Michael brought this up. We're back to the old, garbage in, garbage out problem. And he mentions that, we're all learning that the more information and more rules that you structure around working with AI as you're doing this coding can prevent some of that, or can reduce the debt that's associated with that. But it's a learning curve, and we can't catch everything, excuse me. And I think we're all getting so used to AI at this point that we're just like, oh yeah, I trust it more, right? I think sometimes we need to be a little less trusting, and do a little bit more code review to make sure that things are in the structure. I mean, it's why, tools that have built-in policies and governance are so important, I think, these days, because you can rely on those tools to set, naming frameworks or security checks or things like that. I think the tendency is just to treat it as the Wild West at this point, but we really shouldn't do that. I mean, we don't want to slow anything down, but at the same time, you need some governance there, right?
I don't know if we don't want to slow anything down, but we're doing a lot of harm and uncertainty that we're not reckoning with yet. Because I think what's interesting is when we're talking about debt, it's a almost direct extended metaphor with banking and all. And there's this idea, well, debt's good. Every country has debt. We've created this culture where debt is a good thing. And in the US, it can be limitless, we know. But this idea that, is it intentional or not? Because debt, you're typically signing, you know what you're doing. So I guess it's just the concern, do people know what debt they're taking on? And are they agreeing to take it on? Or it's just an interesting thing. So how often
And
is
what's the interest rate going to be in 6 months, especially when
Yeah.
it's inadvertent and when it's, because that can vary a lot. And we might feel safe today that we only realize how high it is in 6 months.
Yeah, exactly. When often it's broken. And by the way, also code reviews, when it's massive kind of code, it can be overwhelming. I mean, sometimes it can be a lot because AI is professional at creating a lot of code.
and being very persuasive that it's creating
Oh,
good
yeah.
code, even if it isn't. It's very confident in its work.
Yes.
Is tech. But yeah, so what are you hearing about, like, it is tech debt something all of you face customers and talk to them every day that customers care about, or are they still at the stage where they're like, we must go faster with AI? Look at these wonderful percentage improvements of productivity that we see in these headlines that aren't real. So what are you hearing from your customers today? Aaron?
Well, I can go first. I'd love to hear from Grace what she's seeing in the practical world. But definitely we hear that there's more and more tech debt being created. Again, my expertise is in feature flags right now with Harness. And people are on board with feature flags. Like, they get it, they understand why they're important, but people are creating 10 times more than they used to, right? So that's just 10 times more debt that you have to deal with later. And at the scales that a lot of our customers run, that can be millions of flag code out there that hopefully gets cleaned up at some point. But what we're finding is a lot of it just doesn't. And so we're actually on the flip side of the equation now, trying to use AI tools within our product. We just released one recently, which can actually go through and flag for the user, the flags that aren't being used anymore or that have been rolled out to 100% can go into their PR or can do a PR and actually remove the code. And then it's just sitting there basically waiting to be merged again. And so we're trying to find ways, and that can only happen because we know where that code is. It's not something we can just turn on generally for everyone. You have to be using our product to get that to work. But because we do have that insight, we can at least try to help people out with this problem by saying, you determine when you want this flag to go away. We'll go out and find it, do the PR for you, and then you just have to go do the review and commit and merge. So we're trying to make it easier for people to do this kind of in bulk.
Is that a priority for most of your customers though? Like, is it something that they were like, oh yeah, we really need to do that? Or are they like, oh, we hadn't thought of that before, that feature flags also are a form of tech debt?
No, they're asking, and they've been asking for quite a while for a tool like this because they know that it's a problem. They know it's going to rear its ugly head later, and trying to manually fix millions of code changes is not fun or really even in the realm of possibility. So they need to find some way to automate this, and that's what they're really looking for. Now, that's not always possible. There's some tech debt that's bespoke, right? That you can't always go out and find and treat. But I do think using AI to discover this tech debt and maybe as part of a routine process where you can automate it, every Monday, go out and look at this code base and find things that shouldn't be there anymore. That's probably something we all should be running.
Yeah, I was about to say, like, this is a great example of like, we've been talking about it more as a risk, like just kind of like the vibe of the conversation so far. But of course, AI can also help us identify and clean up some existing tech that even like that wasn't even created by AI, right? So like the best example is modernization and, version upgrades and stuff like that, right? Like for version upgrades, you can pair up the LLM with like a code mod tool or something, and that can be really powerful. So the code mod toolkit does kind of like 80-90% of the work, and then AI can fill in the gaps, right? Or for modernization, like it's a really, really good use case to have AI help you like describe and like summarize the functionality of an existing system that you want to migrate to like a different tech stack or something like that, right? Or like what you were saying, Aaron, this idea of like having like I think there's an OpenAI team that wrote an article about where they call it garbage collection, right? So have like agents kind of like run on a schedule or something to look for certain things. I've myself recently done this with something like a modularity review that I can run, or something like dependency freshness, right? Like, are there any of my dependencies that for some reason haven't been updated in the ecosystem in a while, and maybe there's a replacement and deprecation or something? There's so many things where AI can actually help us reduce it as well. Yeah.
Yeah, I actually say that we should be even more strict, not do that maybe on a weekly basis or daily basis. I think that we should do that per commit, while developing the commit to be even stricter, not only for the code review, because maybe I think through development we should have loops where we as engineers integrate with the agent, understand, and also be sure that the code he's writing, we first of all understand what's going on there, and that he's doing stuff in stages. And I think that also the agents should be aware of the code style of the whole repository, how we do stuff, how we used to do stuff, how their code affect other systems that interact with the system we're writing into. So to do that, we should make our agents, I think, more expert. And in order to make them more expert, we should give them knowledge and a lot of context, like plenty of context of the code style, of how to interact with the world. They should be aware of everything, the agents that write the code. And that's how they can become better and match more our style of writing code.
Okay. Does context have become its own technical debt?
It's okay. It can be, yes. Because, just like how you maintain like all the time comments and a lot of context, but we never updated it. That was the problem, because systems move on and context stays behind, and that's a very bad practice. And that's where the agents can fall. But when you make sure by automations, again, by every commit, if something changes in the repository, in the commit, in the methodology, when you have an automation, again, by AI, that suggests an update of the context, and you as an engineer have the ability to see what it suggests as an agent, that will be fascinating because then you will see the changes it suggests, and then you can agree to whether it's correct or not, and you will be always sure that your context is always up to date. And that should be as an automation part, as part of the code we also enter all the time. So yeah.
Agent with specific knowledge and tasks, trying to split that up. I'm just trying to understand. I mean, it sounds really interesting. It sounds a little bit like a skill. It sounds a little bit like I think ChatGPT still does projects where you can give it a lot of information about a very particular task and always use that one. I have one for cooking. I've got one for coding, but it's a very interesting. I wonder if there's ever conflicts in that model, between the two, or I don't know. I'm really intrigued by this concept of developing these little agents, and I love how you keep calling them he.
I enjoyed that. Normally I'm depersonifying, but I kind of like it because so much of AI and especially voice recognition is servile women. So I was like, I'm going to actually let that go because I did think that. But now I want to know, if two or more agents disagree or clash or crash with the train metaphor, how do you even know? Do you know that happens?
Well, you
Yeah,
should be able to.
go ahead.
Sorry. You should be able to because of that map I was talking about. Because if you know, like one agent decision tree collapsed based on the other agents, so there's some kind of conflict, and that's where you should see, oh, is that because that tree you was the one to build it, So you should be able to see that is the problem in the first tree or the second tree? Like you should understand the whole flow. Where did it fall exactly? How did it become to this decision? When you have the very large visibility of the tree and the decisions that were taken, you will be more able to fix the problem in the exact specific place where it fall.
Appreciate that.
If you can see that, right? Because there's all these walls of text when you have especially multiple agents, yeah. But in terms of like, Jennifer, what you were saying, when there's like a conflict or something, I think if we want to take it back to tech debt, right? Like tech debt also often emerges from like all the trade-offs that we always have in architecture and in coding, right? Like we can almost never have it all, right? Like the typical trade-offs like security versus user experience, scaling and response times versus other things, right? So, and that's often where technical debt also occurs, right? Like we're optimizing for the wrong side of the trade-offs and we only realize it later, right? And yeah, I've also been wondering a lot about that. Like for example, if we take like a very low level type of tech debt in the quality of the code and think about static code analysis, right? Which has become super helpful to maybe like find at least like some of the low hanging fruit early on, right? Like typical AI failure modes, like too many arguments in a function, or methods that are way too long or too complex or stuff like that, right? So what if like sometimes these messages kind of like drive, like one of them will drive to another bad pattern that then another message will tell the agent, no, this is also wrong, like, right? So for example, in a React code base, I had it like based on the signals that all of these components are too long, it was kind of breaking them down into smaller and smaller pieces, which is what that static code analysis signal said, right? And then I ended up with like a huge hierarchy of React components that were all like composed inside of each other, which is also not really a good thing, right? And then there was like lots of properties being passed down in there, right? So it's kind of a trade-off that we make all the time as human engineers, right? Like, which of these two things do I want? Where is kind of like the middle ground? But like, does the agent take the decisions that I would take for this, right? When I give it like all of these different signals about the quality, and it has to like kind of find that middle ground. So that's definitely a challenge, I think. Like, I don't know where it's going to go, but I think it's something that we need to monitor and find more of these like conflicts, especially as we let them go off by themselves, and especially as more and more people now are trying to get like ways to give feedback to the agents on their work before they even look at it themselves, right? And we'll get into a loop, right? Where it just tries to like
More loops. That's all we need is more loop
a bad
metaphors.
type of loop, right? Endless loop, yeah.
This is really interesting. So while we've been chatting, the chat has been popping off. And for those that are watching the recording or coding while listening to this or doing your work while listening to this live, and that happens too, there's this idea that if developers are no longer coding, how do they recognize bad code, or how can they recognize what technical debt looks like to then put in the context or knowledge graphs to not have exceptionally long PRs and such? So Reese suggested that, I wonder if getting engineers to actually hand code and implement features from time to time, even while most work is done by agents, would be a more cost-effective way to get a feel for code base health and sniff out tech debt than an army of agents could. And then Mo said that's actually something their teams have started doing. They really enjoy it, and they get to fully write a feature. There's going to be 4 million people graduating, or just having graduated probably a month or two ago, with new IT degrees or boot camp certificates, and all they've ever done is often build a greenfield app to achieve that degree and maybe write some Python. But the idea now is, how are we training not just the agents, but the human developers to smell code rot, to signal, and to then build that context or those knowledge graphs for the agents to not create technical debt, or for the humans, because technical debt is not an AI created problem. What do we suggest to our engineering leaders listening?
Yeah, I think that's a great idea. I was reading that as we were talking, and I think we are going to have to start doing some things like that for the reasons you mentioned. It's one of my concerns, is that the education that we're giving right now maybe isn't correct for the new paradigm that we all live in. I used to think it was okay. My son's a software engineer, right? And so I was really keen to follow along with his journey. And I was like, well, okay, so you're taking this class, you're taking that class. Like, are they teaching you about DevOps? Are they teaching you about CD and processes and how code actually gets created, how features get created in the real world, so that when you get out there, you're going to know what that part of it's all about? And at the time, this was several years ago, before the AI stuff came into play, he was like, no, we don't really talk about that. And I'm like, they really should be, because that's what you're going to deal with when you get to your first job. And now it's like, my concerns are elevated even more, that we may not be producing engineers that know when the AI is causing problems. So I think having these hands-on exercises and also doing hackathons, things like that, where you learn from your peers, you can pair up with a senior dev and a more junior dev, or in a team somehow, and you can go through and you learn from them. Oh yeah, I can see they caught that because they had that institutional knowledge that maybe the younger, less experienced person doesn't have. So I think those types of exercises are going to become important if companies especially are willing to give their engineers time to go do that, because that's going to take time out of their day, right?
This is supposed to be the ideal of AI, is that you have more time to work on the big problems and the creative things. So, but one of the scariest sentences I've heard repeatedly over the last few years is, well, I was pair programming with AI. which I think is concerning because the point of pair programming and extreme programming and programming was group human learning. AI can be involved.
Yeah.
You can thruple or whatever, but it really has to be human led.
Yeah.
Yeah, I mean, there's multiple benefits to pair programming. Some of them actually can be covered to a certain extent with AI, but there's like all of these things. It's all about like teams, shared understanding, and all of those things, right? Yeah. But with this like this topic that we're talking about, I think there's like two sides to this, right? One is like Aaron, what you were just talking about, like yeah, or the new people coming in, right? Like how, or Jennifer, how you said, how will they be able to smell it? But there's also what like all of us who are already in it, right? We're losing touch with what's happening in the code base. I think Giuseppe was calling it in the chat earlier, mental technical debt. I don't know if that's what you meant by that. I hope I'm connecting that correctly. And there's this term that's been coined recently that people are increasingly using, cognitive debt, right? So maybe that's what mental technical debt is, so that if we are in a setup where the agent writes and designs also most of it and we don't look at it that closely anymore, then we kind of like lose touch of what's actually going on. And actually like then when you don't know the design of your own code base anymore, you also get worse at prompting it, right? So you really have to like kind of defer all of that to the agent, right? And for that, I mean, I've recently heard a story from a former colleague where they introduced a new ritual in the team where 3 times a week they actually sit together for an hour and talk about like different technical things that have been happening, like to just like keep that shared understanding. So that's something that they're experimenting with. And then also, yes, like code yourself every now and then is definitely also an approach that I've heard. Or like I haven't done that in a while, but I actually like at least reading what's going on, right? And with this also, then it's always the cycle. AI can help us again like understand when we're feeling like we're losing the understanding, right? Like I'm a very visual person, so I really enjoy like having sequence diagrams at the tip of my hand, tip of my fingertips, that used to be really elaborate to create, right? And it really helps me like understand what's going on and then create a mental model of the code base. So this kind of like more high level mental model, like at which abstraction level will we hit that, and then also use that to communicate with new people coming in to understand like structures and modularization, for example, and stuff like that. And a few grads that I've talked to recently actually like are still developing that type of understanding. But Aaron, like you said, it also depends on the people around you, right? Like what is your lead dev? What is your technical lead around you? And how is the company culture incentivizing that you're not just getting faster, but that you're also investing the time that you're saving into other things. And those don't always have to be even faster on top of the being faster, right?
Yeah, the cognitive loop for developers is getting broader, and Gajetil, sorry for mispronouncing your name, which I'm sure I did, in the audience defined cognitive debt, the growing gap between how much code or context exists and how much any human genuinely understands the cumulative bill of unviewed AI output. This was always a measurement of developer experience, the cognitive load. And I've shared in the chat the Margaret Story.
Margaret Story coined that. Yeah.
Research into this cognitive debt. And then Giuseppe added that we get disconnected from our code and the walls of text, and it just becomes walls of text. And that you need AI to summarize what AI wrote, which doesn't mean that it is a reliable sense of truth either. Aaron?
Yeah, no, I totally agree. And it's why you need to not only create better definitions for AI to use and better boundaries, but you also need to review with your team. I mean, I mostly work on the marketing side professionally, but I work, at home. Well, you can kind of see in my background, probably. I'm very technical and I write a lot of code. And you do end up going round and round, right, with your agents. And not only that, but new LLMs, new agents, new tools are coming out every week. And I think that's also a problem. I found it myself with something that I wrote with ChatGPT 3.5 or something, right? Like, doesn't that sound like ages ago? But that was only, like a year ago or a year and a half ago. And just remembering to go back and saying, oh, you know what, this would be good to have these newer LLMs be able to go back and refactor that for me, or point out things that it really wasn't capable of doing before, would be good to do as well. So I don't know. I mean, a big part of this seems to me coming back to giving ourselves the time and remembering to, making note of, hey, we need to spend some time once a week, whatever it is, to go back and look at this stuff and make sure that it's updated, it's current, it's not leaving anything dangerous out here that an AI might pick up again and use down the road. I mean, I think it just needs to become institutionalized and a best practice for teams.
And we have another term in there called brain fry that was shared: mental fatigue from excessive oversight of AI beyond one's cognitive capacity, leading to more frequent errors and burnout, because we've been talking a lot about the developer side, but don't forget about the ops and security side. Grace?
No, this is not going to happen this way. So I created, my own development train where I take a task and then I have to the understanding core. The first core was to understand what's going on. And in this core, it's the opportunity for me, the very first core, to understand the task very well, both on the technical side and both on the system side, like where will it be technically done, in which files, which line of what's gonna happen there. Understand that the decisions taken are actually correct. Now, this is a great opportunity for me as a developer and an engineer to learn of what's going on there. And then I understood while developing this whole development train that I need some human in loop gates, which are, while the train is going forward and developing, there's pauses in key points. And I'm not gonna pause like only at the end when the code is ready and it's hundreds or thousands sometimes lines of code. I'm not going to do that. I'm going to pose in very smaller key points part where I have the opportunity to object, to reject stuff, to debate stuff, and to brainstorm along with the AI. Now, that's the whole point of also while you build your agent or your agent train, as you want to call it, you have to take into consideration, because we can control agents in the way we build them, that we need in key points to pause stuff and to look into what we're doing as an opportunity for us both to learn and to make decisions as an engineers, because that's the whole point of an agent. We should lead him, not he leads us.
Right, right. And I think that can be a challenge for, especially right now, as a lot of companies are leaning in. We've all seen the memes, like people are getting measured by how many tokens they're using, that which should not be the case, but it seems like it is these days. But I think that what you're getting to, and to tack on what I said previously, is that this needs to be institutionalized and it needs to come top down. And leaders, right, that are listening to this need to understand that they need to give their teams time to do this, or they're going to have problems. And maybe for those that are listening that are not leaders, maybe they're practitioners in this space, maybe one way to do this is to go out and find an inefficiency, right? There are ways, of course, to measure things like speed and performance and those types of things. Maybe it's worth spending some time to go out and find an inefficiency that was caused by tech debt, so that you can take it back to the company and you can say, look, our application can work this much faster, our application can generate this much more revenue, but it's not because we're not dealing with this tech debt. That'll open up a leader's eyes and say, oh, wow, this is important. This is something we need to allow our devs to spend time doing. And then you can hopefully institutionalize that practice. And like you say, Grace, put in more checks earlier in the process. We all think about doing it before it goes to prod. Well, hopefully we do. But you're right. You need to be doing that consistently throughout, so that it doesn't become a huge exercise at the end.
Yeah, and also we have some great ways to make it less overwhelming, like doing it with questionnaires, for example. Let the AI ask me questions to make sure my answers actually go on with his idea or his concepts that he got. This is a great idea for us not to write a lot, because none of us wants to write tons and tons of lines to make him understand. So he will just ask us that multiple type questions, and we will just answer and make sure that we agree on the understanding.
Yeah.
Absolutely. And I think part of it is, since we are talking to mainly engineer leaderships, it's the same problem as before. We need to be able to advocate to pay down tech debt to the budget holders and the C-level parts of a company. But usually for any changes, right, I say it's for AI and they'll be okay with that. But how can companies convince this priority and the priority that, like, you know, we need to retrain engineers in this whole new world? How can companies make that case? Yeah, everyone's silent when I asked for the advice of how to.
So that's the question. Okay, yeah. I mean, one thing that I always talk about that that I find like a really interesting flip is like to flip it from like a negative thing to a positive thing, that we all define how it's defined, right? So to not talk about tech debt, but to talk about what does health and what does quality mean in our organization. So the first time I heard this kind of like done is there's this company in Australia, REA. It's like a real estate listings company in Australia, and they do that, right? So they have a definition of what good looks like. With almost like a maturity level for services and stuff like that, in terms of like developer experience, architecture, our fitness functions defined, our like, observability, those types of things. And then it's almost like a service level objective, right? So all teams that have something in production, they have service level objective, and it's a shared understanding that when you don't hit those, then you have to invest time into that, right? It's a shared understanding with the product side as well. And so it's kind of like almost, or at least that's how I interpret it, like the similar way to say, when we don't hit these like quality standards for observability that we want to have, then we have to invest extra time in this, right? And then the discussion actually becomes about the good state and why we want this, and agreeing on like, we need this so that. And it doesn't become about like some fuzzy, like I was saying in the beginning, definition of debt, and where people are having a hard time distinguishing, is it like a beauty thing, or is it like something that's actually something good for the business, right? So that's like one way to flip the conversation around a little bit. And then AI, of course, can also have a part in that. And maybe for some things we can even argue easier now, because again, AI can also help us make it better, right? So that's like the weird thing about this, that, yes, we're worried about making it worse, but also it can help us, right? So we just have to be careful. There's this German word, compound word, Verschlimmbesserung. So Verbesserung is improvement and schlimm is bad. So it's kind of like you're trying to improve something, but you're making it worse, right? So we want to avoid that, but we can use AI to help us with some of this tech debt. So that's like, indeed, as you said, Jennifer, it's like a new lever that we can put in there. Yeah.
And you can post on LinkedIn a step-by-step pronunciation so we can adopt that in our vocabulary, please.
Sure.
So I am so grateful to each of you for joining this conversation, and to the audience. I do recommend that everyone join us in the Slack channel, because we do have more questions to answer. Just to give a little preview, we're going to talk about more into how teams are actively creating less technical debt. And I think what Birgitta said of establishing those definitions of what good looks like, what health looks like, is a great way to start that, because you can't really avoid what you don't understand. And those definitions will be different by an organization. And those will be helping, create the guardrails that doesn't create more technical debt. And then we've been asked by the audience also, like, how do you get engineers on board with this that are maybe demotivated or burnt out or brain fried about all this? And I think these are really important conversations. So for those of us that can join us in the panel Q&A Slack, where you can continue the conversation, thank you so much. And I look forward to continuing this conversation. Have a good day, y'all. Good luck.